we can get started. Any company update from you?
Not really. No updates yet on. Well, apparently next week we're going to get some 5090s, but I'll believe them when I see them.
Great. I think I would be giving a talk, or there's a study group that they are studying kernel stuff in person in New York. Twitter, I say I can give a talk, and the organizer, okay, sure. So I'll probably prepare something for that.
Cool.
Mostly, I think just to show, since they are interested in reading kernel code, I'll probably just show some examples from similar to abstraction, like top down, and maybe show some like tools like Viz and like sim and front end supporting different kinds of backend and go from there.
Yeah, I think one of the most interesting things about kernels is like the opt-ops and what they do. What like an unroll and an upcast and yeah, what these things kind of look like.
Yeah, I have some examples, maybe just the simple ones, and I just want to provide it in a way so that if people are interested, they can. There's like some examples for them to try TinyGrad to start with.
Yeah, no, I mean Viz is a great way to teach this stuff too. We need like a tutorial for speed.
Yeah, and I also saw your other speed doc. I think similar to abstraction. I think these things attract people.
Yeah, I hope so. Yeah, I'm gonna put some effort into that.
Cool. Yeah, I will share whatever I come up with later. Okay.
Cool.
Let's move on. So, so for speed, there's George, this is all for you.
Yeah, no, I did a lot of stuff on CI last week. I upgraded us for $100 a month to the GitHub Organizations Enterprise or whatever it's called. But it gives us 500 runners. So we can use a lot more runners now. We still can't use more max. We can only use 5 max, but we can use more Linux runners to pretty much do whatever. So it hasn't really made CI that much faster, but now a lot of CI completes faster. It's pretty much just like NV that's still slow.
Yeah,
And
I think
I think there's
the Linux NV1 is probably still bottleneck. It takes 12 minutes.
yeah, and I don't really know why like Linux NV is so much slower than Linux PTX. Is it compile time? Is it I don't know.
Okay.
But yeah, no. So we can use more CI runners. I also refactored the CI code looks good now. I refactored those YAML files to actually look decent. I made some sub actions for process replay and for environment setup. So it's really easy to like add another runner, read benchmark, read test.yaml if you haven't. But yeah, there's just like sharing our code, set up environment, run your tests, and then add process replay action at the bottom if you want.
Great. Okay. LLVM.
Yeah, so I did 2 streams this weekend for LLVM speed. LLVM is really nice. So the only things it seems like we're really missing are just a bunch of opt-ops. I did a stream on Sunday that shows how to fix the reduce thing. So with just adding a few more opt-ops to Beam should do that. There's this concept also of like adding horizontally that maybe doesn't exist in the opt-ops. I haven't totally thought it through yet, but it's up there. It's a bounty. And I want to get other people excited about working on speed. This is definitely doable now. It's doable to get LLVM speed that exceeds Torch's speed with not that much work. I've also been working on devectorize equals 0. So devectorize equals 0 doesn't do the devectorization before it renders it to the IR. It keeps it vectorized. It's really annoying in the DSP. So I wrote this like revectorization thing, and then I was like, this is stupid and super slow because it like devectorizes to 128 and then it revectorizes. I think we'll try to keep it devectorized, so that'll be fast for the DSP. The trick to making the DSP good is that you have to do things. It's an 124-bit vector machine, so you have to do things in 128 byte chunks, and that's an upcast of 128. So that's a lot bigger than the other ones we've been seeing. So that's why devectorize is really nice. Yeah, we have some things getting like 30 gigaflops now on the DSP. On the real DSP too. I got 35 on the actual DSP hardware. So
What's
that's
the limit? What's the limit for that?
the theoretical limit supposedly is 3 teraops. But it seems like SMPE gets about 80 gigaflops.
Uh-huh.
So that might pretty much just be what we've been doing plus 2 cores.
Oh, I see. 75 times 2. Okay. 35 times 2.
35 times 2, yeah. There's 2 cores you can use, but that's the last thing I'll do. There's a lot of lower hanging fruit than that. Also, this morning I wrote a nice QMU will tell you the cycle counts, and if you just take how many cycles the thing runs, and if you just take that and divide it out by 1e9, it gives you a pretty good idea of the time for 10 gigahertz, and that's it.
I see. Great. So contract on track.
Yep. That's gonna be what I'm working on for the rest of probably this week and next.
Okay, sounds good. Oh, before we move on to the next one, I think so you changed the commutative to be integer only?
Yes, is that bad for some reason?
Yes, because we are trying, there's a bounty to flip and sort things in a chain, and that basically needs commutative.
Yeah, so the problem with commutative is sometimes, and I'm not exactly sure why it happens, I guess this is less of a problem with devectorize, but sometimes for some reason, like 1 or 2 of the vector items will flip. And then if 1 or 2 of the vector items flips, it can't revectorize it. So yeah, if I'm using devectorize, you can put it back if you really want it.
Judging from how you change the code and no test really was broken, I think if we want to add it back, we probably need to add more tests around that too.
Yeah, no, I definitely. There are tasks that will break if you remove the integer, because it's how it does the constant.
Yeah, because the current test probably only build on variable of integers. But okay.
Yeah.
Okay, no problem. I will figure it out with the person working on the bounty.
Cool.
Okay, moving on to the things I did. So I moved the PAL to be an ops, so it's no longer in Tensor, and most of the logics are moved to one of the 2 graph rewrites. So I also removed another place in the get item that try to extract the const from Tensor, so we don't have lab behaviors anywhere in Tensor now. So we don't have that to const val thing. Small issue to bring back the behavior for get item, and similarly to fix a lot of the cat and pad in the kernel is because currently for gated load and store, we only rewrite it as a where in the renderer, and that's too late if you want to. So there's a lot like
Well, you can't really write it as a where. I've been thinking about this too.
okay, why not?
Okay. So let's just talk about a gated load. So if you want to write a gated load as a where, you're imagining the where being after the load, right?
Uh, you mean in UOP representation?
Yeah.
So yeah, so the load will be a source to the where.
The load would be a source to the where. So the problem with that is if the index is something out of bounds in memory, it could crash the GPU.
Yeah, but shouldn't it be tied to the load?
No, but
After
what if
lower, after lower.
after lower, yes. After lower, if you have a gated load, some of the things where the gate is false, where it should be returning 0, are out of bounds memory access. So the load actually has to not happen. And if that's an input to the where, that means that the load happened.
It's not short circuit.
No. I mean,
Then how
there's
does the
no
current
guarantee.
code work?
The,
Current
the
kernel code also
current
rendering.
behavior, yeah, the current behavior in the renderer is short circuit, yes. But there's
So
no guarantee if you just put an arbitrary where afterwards that it'll be short circuit. And then think about like, how would you do a gated store using that?
we probably don't need gated store. We can focus on gated load. I'm still not too following if we guarantee that your where. So basically conditional on valid or the where condition is true, that load is always safe. I don't
Yeah,
see
conditioned
how,
on the where being true, yeah.
yeah, but I don't see in what condition we will remove that where condition for that load.
Again, you're making an assumption that a where is a short circuit, and that's true in C style, but it's not true in LLVM, for example.
Is there a way to make it true?
No, it can't be, right? Like by design of
Yeah.
the UOPS, it can't be true. It's also not true in PTX. It's not true in assembly language. It just happens to be true in C.
Mm,
Like you can look at the implementation in PTX of like gated load, and you can see how it differs from the
I see.
implementation
Okay.
of where. You actually
Okay.
need that load not to happen. So I have another proposal.
Okay.
My proposal is that you put the where in front of the index. And then like, so it's like load from an index, and then the index has the buffer as the first one, and then it has a where as the second one. And that where sets it to a poison value if the valid is false.
Yeah, I think that is similar to the current gated load in the sense that I was just not sure if I want to rewrite this where merge. So we have the where merging rules saying if the conditions are the same, we can merge it. If we
So,
want to separate these, so now we have cases for like gated load to gated load to a where, and where to a where.
well, I think you also want the where. So the poison thing doesn't get you out of the where. Right? Like, so you'd put the where basically in two places. You'd put the where on the index and you'd put the where on the output.
Yeah, my point is just now the same where merging rules. I need to repeat it 3 times.
Um,
Like for
yeah.
cats, yeah. So that's a main issue. I was trying to see if there's a way to get around this.
All I can say about this for 100% certain is that you can't just have a where on the output of the load because
That
the load does
I
not
get now.
happen. Yeah.
Okay.
But if you also put a where on the index to give it a poison value, this kind of fixes it. Also, the thing I like about that where with the poison value is it kind of specifies how to do those, like, you know, those index folds you do? The index folds where it's like based on the gate, you can not compute some things.
Yeah.
Like that becomes a just purely mathematical rewrite based on that where.
I see. I see. Okay, I
Right?
will
Like
think about it.
it's yeah.
Cool. Okay. One last thing. So for ResNet, I was trying AM driver. I don't know. I saw Nimogen has a lot of fix on that, so maybe some of it is that sometimes I get very weird values and weird results, but if I pull to master, sometimes it works. So maybe we can discuss about the status of AM later. But for AMD, ResNet crashes always, but for AM it seems to run fine. So not very useful to debug AMD, but good job for AM.
Well, when it runs fine, does it get good values?
Yeah, so at the most recent one, they get similar values to NV. So we still don't know about the convergence issue, but it's similar to NV, so I don't think it's specific to AM.
Great, we made a better driver than AMD.
Great. Let's move on to scheduler.
Right. So I have the kernel refactor ready. I'll post the benchmarks preview in the scheduler channel. As you can see, the Python time just increases substantially for a bunch of stuff. So I'm working on just optimizing Python speed last, but it's correct. And what you can really do is like assigns can depend on other assigns and preload is gone. So yeah, I'm planning to get
Before
that
you,
merged.
that speed diff doesn't look too bad.
I'll leave it to you. I mean, you can click merge.
Which is the which PR is it?
It's this one. 8925.
All right, sorry to cut you off.
It looks like 10% slower.
Yeah, do you want to explain it for everyone here?
Sure. So this is about resolving how to tuple sort the different kernels. So what the scheduler does really is like take a really big graph of tensors and break it into kernels. But once you've broken it into kernels, you also have to tuple sort them in a way that the output is correct. This is easy for most of the time, but it's hard when you have assigns because assign means that a buffer can have multiple values depending on which kernel ran first. So what we have right now is a hack called preload. This hack is very limiting and it's also fragile. This hack basically says, okay, if you have a preload of a buffer, do this first before doing the assign, otherwise do the assign first. This limits us in two ways. One is that like there's extra rewrites in there, there's extra complexity, but the biggest thing is that you can't have multiple assigns scheduled in one kernel, one schedule. So what we have here is like a refactor of exactly what exists in the linearizer for the UOPS, but expressed in the tensor kernel style. So far, I have gotten it to a point where you can have multiple assigns depend on each other, and the existing test work as expected. Realization happens before breaking it into blocks. So it's sort of like it looks up the realizes map to see, okay, does this tensor end up getting realized? Otherwise, it just appends it to a kernel. So if you visit, you can actually see like things being gobbled up into block kernels and getting connected together. That's the basic
Yeah,
idea.
I gotta look this over with Viz. But okay, so it's basically that same assign depth thing, but you removed all the BFS code.
I did
Replaced it
not
with
remove BFS. I put BFS back because ResNet seems to uh,
um,
have memory issues when I do DFS. So DFS is correct, but we have to understand why BFS is required to make ResNet work.
I see. Can we I mean I'll give this a try tomorrow, or you're welcome to merge it if you think it's good. Can we separate the idea of like grouping and scheduling? Like, can we rewrite the tensors with the kernels in their history, in their parents?
The way I imagine it is that realization, the grouping should happen before the kernel is run. Right,
Yeah,
the kernel grouper, the append to kernel, the append to block, whatever it's called, should have a reference of which ones to append and which ones to not. It's
the
a separate
grouper.
constraint.
Yeah, the grouper should definitely happen before anything runs. So what I'm saying is the scheduler could actually put things back in the tensor graph, like put UOPs in the tensors that point to kernels.
I don't understand. Can you explain? Tensor UOPs becomes like you said about the Super Mario thing. It's like
Yeah, well, yeah. The Super Mario thing, it's kind of like you can think of the kernel graph, like the sked sync, as the overworld. Right? And then you can zoom in on each one of those kernels, and those kernels are like the levels. But no, what I'm saying is like, so right now, the scheduler still returns this list of schedule items. Right? Instead of returning a list of schedule items, what you could do is update the graph to have the kernels in it. Or have we thrown that information away by now?
you can literally like return sketch sync from the scheduler and put that BFS or topo sort, whatever it is, in realize.
Yes, but we'll talk. We'll talk about this offline. But yeah, I think this is a good direction, and we can separate the like sked sync from the other stuff. We can think about how we want to do that.
I want to move on with this because it's like preload has to go. I completely understand preload has to go. I'll work on making this fast. If you don't want to like click merge right now, you can give me feedback on after we visited it.
No, let's just click merge. Let's just merge it.
Okay.
If you think it's good, go ahead.
10% is
Yeah.
fine. And there are
Yeah,
other
10%.
more systematic way to make that fast. It's still pretty slow, but not for this specific PR.
Okay, merged.
Probably want to test with benchmark, or was it test on benchmark?
It was. I ran in some benchmarks with times. Yeah.
Great.
Great.
I'm gonna work
Well,
on your don't realize expands and make that generic. I don't know what you want from that.
Oh, from don't realize expands?
Yeah.
What do you mean by generic?
I mean, can it be made generic? Like, is that the thing we should focus on?
It's an important thing that we want to focus on in the next month or two because that has a big impact on training BERT. But unless you already have a good idea, so for like when do you want to expand or when not to expand, because I don't know if George does. We can only do
Yeah,
that like what to do with the expand.
yeah. When you say make it generic, so you don't want do realize expand. You don't want don't realize expand. You want sometimes realize expand. But figuring out an answer to that sometime is not that obvious to me.
Yeah, so that should be probably want to like run over a bunch of kernels and either having other heuristic to make a decision or find a set of rules that is good enough. But for now, we don't really know, so that's why our current rule and with that special flag try like the two things, and you can observe that for individual kernels. That's where we are now.
Yeah, I think there's a lot more cleanup to still do here too. There's still a lot of stuff in the schedule context. Do we need all these things?
As long as there's custom stuff that I'm maintaining for the reduces. Like that's the oldest part of the scheduler right now. The thing.
What do you mean?
Well,
Oh, also,
there's this. Go ahead.
did you bring back multi
I'll
output?
bring it back. This one. I'll bring it
Yeah,
back.
that's a good thing to do. Cool.
But like multi, if I can bring it back, it's again custom stuff. So there we have like custom DFS. It groups the reduce ops with the children. I did a bunch of refactors last week to just like sectionize the scheduler. We only need the context for that. The context lifetime is that place. It starts and
I
ends
see.
with the custom stuff. So we don't need the
Yeah.
context to do the other stuff.
Yeah, taking it out of there would be good.
Like the only way is like rewrite that into rewrite rules. I'm not sure how. I don't want to keep maintaining it.
But messing with the expand thing is actually, if you wanna play with that for Bird, is actually very easy now. You can just right where it says don't realize expand. You know, you can just do whatever you
Yeah,
want from there.
I try that, and sometimes it got faster, sometimes it got slower.
Yeah. Welcome to sometimes realize expand.
Okay. No, it's not. Let's move on. Or anything else to add?
I'll write up tomorrow the stuff about separating the grouping and putting the grouping into the overworld and see if this is feasible. I'm basically saying like maintain tensor map for as long as possible.
I see.
Oh, are the views gone too? Is it now always movement ops?
Oh yeah. Yes, I merged that.
Oh, great.
So like it's sort of like realizations. We're getting to this point where diffs are like 5 lines, less than 5 lines, but it's like okay, this insight we missed and it broke a bunch of stuff. Like the most correct way to represent a realized tensor base is a reshape on a buffer. Then you can do all the fancy stuff with the cast before views or whatever you want to do where you actually make tensors become views of other tensors, and that view can be anything, right? Because it's movement ops all chained together, and that view thing, I don't need that anymore. I fixed that with a nice property of substitute. It just worked.
That's good. Okay, let's move on to drivers.
Yeah, so this week, so I added support for 7600 to AM. Basically, it's like AM is now more generic, so it can just read versions directly from GPU and load the correct firmware and registers offsets and yeah. So yeah, also fix the power consumption and this GFX utilization with at 100%.
What are we down to now?
So yeah, it's 18 watts for 7900 and 3 watts for 7600.
Great.
Yeah, so this week I'm just going to continue working on the USB GPU. I've been reading firmware, so yeah, but not much progress there.
You've been reading the firmware for the 24.
Yeah, I mean, both of them. I'm just comparing them.
Yeah, I mean, it'd be cool as a first step to get the 24 working like we have the 23 working.
Yeah. Okay, yeah. I think, yeah. But yeah, I mean, yeah, just trying to get the full picture of what's happening because yeah, some parts of difference between them and just doing it straightforward on 24, it doesn't work for some reason. So yeah.
Yeah, we don't actually
Like-
need to support 23s. I don't care about 23s. If always supports 24s, that's great.
Okay, yeah.
Just there's a chance that the 24s are going to do the like fast DMA thing differently.
Okay, yeah. So but
How's
actually, I mean, yeah, okay, yeah.
how's the move to AM for everything going?
I didn't get the question. Can you repeat it?
Oh, how's the move for the benchmarks to AM?
Oh yeah. So actually, I just did it and then just reverted because during this week, and I just some fuzzers I found a strange behavior on the ResNet. So yeah, I'm just going to look into this also this week, and also into the page fault EU code and CI. So like yeah, I've just been investigating this. Like the address is correct. I mean, maybe it's something kind of the race. So yeah, I just started added some barriers to our Python code. So yeah, I'll just fuzz this more.
Yeah, I saw the atomics. I think yeah, let's fuzz it. But let's also stop inserting AMD GPU. I have no idea what that thing's doing. I'd like to just keep it out for the benchmarks. Maybe we can have one small section where we just do like a regression test just to make sure that that behavior is still supported, where we insert it, do the regression test, remove it, and then we never insert the AMD GPU module again.
Yeah, okay. So I mean, actually, this problem when we get some stale pits. I mean, I think it's happened because when we just cancel workflow or just it's timeout. So I think it's more related to how we stop these pits, or like GitHub CI stop these pits. So maybe we can change that so we do not have problems with this memory usage in CI.
So those are happening with AMD GPU or with AI?
So actually, I think both of them. So it's actually, I mean, with AMD GPU, AMD GPU just reserve this memory for this speed because this speed is kind of still alive. And for AM, I think Quasalin also saw also like the log files, so to access the GPU also were taken. So I think we're just not properly killing some pits.
Yeah, maybe we just need like an exit handler or something. We need to figure out what signal GitHub Actions sends. Make sure we handle the shutdown. Cool.
Yeah, I think for now, if you got weird behavior on CI, what I did is you log into the machine, find the stall process, and kill it. And that's pretty much fixed.
Yeah, I was doing that too, but I like the idea of just like moving to our driver, and then we know that all the bugs are our bugs, and then we just gotta fix them.
Yeah, that's the goal. I think for now the issue is there are some bugs still in the AM that if we use AM for everything, it has issues sometimes. But looking forward to that.
Yeah, we got to figure out how to get fuzzers on there, finding those things. I mean, we can also put we got 6 more red boxes I can plug in if we want more red boxes to do fuzz farms and stuff.
Okay, great. Lots of red box.
Lots of red box. So yeah, no, Nicholas, do you think the like fuzzer will keep finding things if we run it for a long time?
So yeah, I think I mean,
Yeah, let's try to write
definitely.
the best fuzzer we can, and then just run it for a week.
Mm-hmm. So yeah, I just did some overnight runs on some machines, like for the ResNet. So yeah, I think
Great.
yeah, if we have more machines, I would like to keep doing this. Yeah, and
yeah, I mean we have a whole bunch now we can use. I don't know. I'll have to get those new machines plugged in. That's going to take time. But actually, we're out of power right now.
Oh, the tiny room?
Yeah. You know, the
Okay.
tiny room's out of power. The compute cluster has more power. But yeah, no, feel free to use like 32 and 15 and just run fuzzing on them constantly.
okay.
Okay. Yeah, just coordinate in the access channel. Okay, let's move on to Tensor course.
Hi, hello.
Hello.
For me, it's AMX. Basic AMX support for LLVM is now ready for review. As I said, it's not. It's like the same support as for Clang. Like it's almost matches LLVM's output with a level of optimization 1, but it's working, and that's it for me.
Cool.
Not
You know, it looks simple and straightforward. I think I will yeah, can I just merge this?
Yes. I mean, maybe I ran the tests locally, but a benchmark run, and if it passes, it could be merged.
Cool. Yeah, no, I'll do a few tests tonight, but yeah, I think it looks good, and that bounty is yours.
Okay, cool.
You want a big bounty for making it? You know how to make it fast?
It's like it's working in kernel.py. I would
sure
write.
I'm not sure it's
Yes.
just kernel.py. You know what? I'll throw $1,000 on that bounty. And do you want me to lock it to you?
I'm working on the other on the D-type stuff. Like I'm not going to be able to multitask in many things.
I'm more
Okay,
interested.
that's
I'm more
great
interested in the speed. I'm more interested in the speed. There's a $500 bounty. I'll double it for you if you think you can do it.
Well, I try this week on focusing solely on that.
Great. Yeah, $1,000. We need like TinyGuard's a combination of stuff that's all breadth first and depth first. Let's go depth first and let's make that AMX fast. Do you see sort of how to do it? It's not kernel.py.
Yes, I mean hand coding the kernel. I have an idea.
Cool. Yeah, it's fun. It's fun, and it'll show that that you can work on a sort of like a different part of TinyGrad. And I think that's a good path. Yeah, you got to kind of create. It's kind of like right now we have define ACC. We have define ACC, define local, and define global. I think this is more than just the AMX thing. This is kind of more generic. So you want to add another UL. Like define ACC. ACC is the wrong name for that. That's actually a register, right? Define ACC is a register. And then define local is like the local memory. So there's like there's a fourth kind of thing, which is like special register. So you can add something like define special register, and then add loads and stores to that special register, and then have them cancel out when you do the accumulate.
Cool. I don't know if you mean. Yes. Great. I'll focus on it and try to make a good Good work.
Cool.
Let's also add a channel somewhere for the CPU program or LLVM or claim speed. I don't think we have it.
Okay. Yeah, we'll just call it CPU speed.
Cool.
Yeah, I was thinking. I bought a notebook this weekend. I was writing in the notebook, and I'm like, assign? What do we assign to a defined ACC? That's not really the right thing. What we really want to do is store in a defined ACC. It's like a store to a register.
Yeah.
Yeah. And then I was thinking about how like loops, how range is kind of the wrong abstraction for loops because range itself is the induction variable. But we could take the range and rewrite it as a defined ACC add one compare kind of thing. And I'm thinking of like other ways. And I was trying to get ChatGPT to tell me like how compilers represent loops in DAGs, and they don't. They only have DAGs for basic blocks. Basically, they have a separate algorithm which does basic blocks. So yeah, we're pushing the frontiers of data flow programming languages in compiler tech, unless there's papers that ChatGPT doesn't know about.
Great. Any update for Onyx? I think I need to review one Hugging Face script PR. Anything you want to add? You can type. Okay, and while we wait, let's move on to other bounties. Starting with WebGPU Flow 16.
You have speaker rights if you'd like to talk about it. Actually, I clicked the link on my phone, but then I got impatient. I wonder if it finished.
There's a link.
Yeah, there's a link in the WebGPU thing.
No, this is for the WebGPU Flow 16 support.
Oh, not Float 16. Oh, okay. So this is TinyChat. Sorry.
Yeah.
WP Med. Oh, you don't have speaker? Oh, now you have speaker. Sorry.
It's 8653. Looks all green.
Oh, sorry for the background noise. So the first part of the bounty was auto-generating the zone engine, and that merged. And the second part is also ready for review, which is actually adding the F16 support.
Yeah, I see. I see now it's D-type supported, support have, and
Yeah, and I added a bitcat a string rewrite because so there is no short and U short in WebGPU. You only have U32, and that needed special handling. So it's 6 line overall in core.
it's probably fine. Do you have a link to Stable Diffusion that you previously deployed by in Flow 16?
Yeah, it's in the WebGPU channel.
Oh, okay.
Yeah.
Gradient up here looks good. I will test. Okay. On my list to test tomorrow is this one and the AMX one. And I think they both look good. and I will test them tomorrow and get you guys the bounties. Do you have other suggestions for new WebGPU bounties?
So can you repeat the question? Sorry.
Oh, do you have suggestions for other WebGPU bounties?
I think like it's mostly for WebGPU, but I think it would be really good to have export model in 4 because I had a for a client they wanted to port their stuff TinyGrad stuff to WebGPU, and like if you just pip install TinyGrad, you don't have export model. But I think it would be really nice if you just had that when you pip install. So you have to actually clone the repo and stuff because it's an extra currently. So like it's a bigger. So I think it's a bigger bounty, but maybe that would be nice that you can use that. Like so, yeah. I think that would be nice.
So you're saying bring export model logic into main TinyGrad?
Yeah, exactly.
Cool. I'll put $1,000 on that. Export model in main TinyGrad. It is a refactor bounty, so I will lock it to you. No pressure to do it or not do it. The problem with refactor bounties that I don't lock to somebody who has contributed before is you get the absolute, I'm going to get somebody who just is like, oh, I just need to copy and paste this file. ChatGPT told me I just drag it into this folder and now it's in main TinyGrad. Please pay me bounty, sir. And that's just not how it works. But yeah, so I'll put $1,000 on that. I know you're doing contract work using WebGPU stuff. So if it helps you out, if it kind of is already on your path already, I'll put $1,000 on making it clean.
Cool.
Sounds good. Move on to TinyChat. I tested on my Pixel phone and it seems to work fine. Similar speed to like I think 5 tokens per second.
Whoa.
Cool. Glad to hear that. Yeah. Yeah. So pretty happy with some progress I made in the past few days, where I was able to get WebGPU to work. At least on my phone, and I think on maybe hopefully on newer phones, it's or at least on my phone, it seems to work very smoothly. Rarely crashes on load. I only ever get crashes on load, but the WebGPU load seems to be very stable. Loading the WASM version, it's less stable. I'm still figuring it out. I think I've narrowed down where it's failing, where it's crashing on my phone when I load WASM, and it seems to be copying data from the main JavaScript space to WASM module space. That seems to be unstable when you do a lot of those copies, using the typed array.set method from the JavaScript byte array to the WASM instance's memory. So I have A/B tests where if I just don't do that and just let the arrays sit, I don't crash. But if I try to copy them into WASM, I crash. So not consistently, but it just seems to be the root cause right now. So I'm trying to work around that, trying different ways to get the data into WASM. This is just like the icing on the cake. Like it sort of still works if I just refresh the page after it crashes, but I want it to just be really smooth. And then that like sort of gets it to where I want to be. And after that, it's just potentially some minor things like increasing context window, because right now it's only like 1024 tokens. And then of course once you go over that, the model just spits out gibberish because memory access is probably just undefined behavior or reading into other parts of memory at that point. So if we can just increase the context window a little bit, and then some other minor things maybe if they're quick. But once that's done, I would then just try to get my code cleaned up. I was pretty interested at what you guys just discussed about the export model, moving that into main TinyGrad. I think that's a great idea. I think a lot of the value even of the TinyChat bounty is just it's not even really the app itself. It's just showing people, hey, like you can build this kind of thing with TinyGrad, right? And so people might want to, yeah. So I think that's a great bounty. I was almost going to try to do, not move it into main TinyGrad, but try to make my compile stuff cleaner. And I still will try to make it cleaner, but now I have to just keep that in mind. That maybe I shouldn't try to do too much if it's going to be covered by the other bounty. So yeah, just trying to clean it up and then that's it.
If
do
you're
you
interested in it, too, I am happy to. I'm definitely happy to split the bounty, or you guys figure it out how you want to like. I see this being kind of a big effort, and I think it's really valuable. And I'm down to incentivize it more. Like I'm down to pay $1,000 for that bounty, $1,000 for export model. If there's like another $1,000 bounty here, like WebGPU is worth several $1,000s to us. Probably not 10,000, but something like 5,000 total is probably like for like a really clean way to export things to WebGPU. So I mean, yeah, we run into sort of the issues with the exactly what's a clear bounty here. Especially anything that's a refactor. But yeah, I'll
let's
you know what?
figure this out, or you?
Yeah. You know what? I'll lock the bounty to both of you, and I'll double it to 2,000. But I want it to be really nice.
So specifically for TinyChat, do you know our current speed of loading the model is already like close to a limit? I think there's definitely you need to wait. Even if you have downloaded the model, loading the model to memory time is still pretty long. And I don't know if it's close to a limit now.
If I understand the question correctly, you're just trying to understand like what's taking time in the entire launch process. Is it
Yeah, can it be faster? Because George also said he got impatient, right? So
yeah, so I intentionally like had to throttle the or I'm not sure I'm actually throttling it, but I had to limit the concurrent downloads on phone to like 2 because or it seemed about the same as 5. I'm not sure that it even makes a difference to add more, but let me break down I'll try to be concise here. Like
so I have already downloaded the model, I'm pretty sure.
okay,
If
so
it's
from cache you mean?
yeah, so I'm just curious now. Every time I refresh the page, it still says loading the model, and the load takes some time.
Right, yeah. So I think it's just I think the main bottleneck there, and I could be wrong, but I think it's just the time it takes to read from IndexedDB into memory. I need to go and actually benchmark to understand, like to profile it. I don't have a good answer for you right now, but I think
Okay.
it's some split between reading from IndexedDB and then either writing to a GPU buffer or loading into WASM memory. I need to profile it.
Are you
But that
doing the GGML unpack there? Are you
no.
like unpack from 6 bits into?
Right. So there's 2 separate things there. So one, I've actually completely got rid of the GGML stuff. It's all quantized from float 16 to in TinyGrad. So from the float
Wait,
16.
but if you're doing float 16, aren't you downloading double the size?
Right. No. So here's what I do. I have the when I compile before anything ever goes to Hugging Face or the browser or anything, just on when I'm compiling and preparing everything, I take the float 16 weights into TinyGrad, I quantize them, and then I save them to disk, the quantized weights to disk, like split up into chunks, and then I host those. So the only thing
But
that's ever
quantized to
downloaded.
float 16, but it is still double the size of the GGML one.
No. One thing I don't think I mentioned it, but I used the quantization of the linear layers that was already implemented, and I implemented my own int8 embedding quantization in TinyGrad, and so
Cool.
everything is being quantized to int8 with float 32 scales before it ever gets hosted. So this is different than it was a week ago, I think, but basically you're not doing any decompression after you download. It's just loading, it's from IndexedDB, for instance, directly to model with no decompression.
Got it.
So the whole download size is the same as what sits in memory on the, either in WebGPU or in, in host memory if you're using Wasm, which is 1.2 gigabytes. That's what you download. That's what gets loaded to the model.
Cool.
So yeah, I'll
so I
profile
doubled.
that. Yeah.
Great. I doubled the export bounty, export model bounty, $1,000 each if you both work on it. Very clean and documented code. But if we could really get this in main TinyGrad, meeting the quality requirement of main TinyGrad, I think that's very valuable.
Sounds good. Let's move on to Rekinanet.
Hello. So for mine, I think I guess I just have a few little small updates. My end. So the first one, I've tried to play around with the model inference for the model eval script using the new data loader implementation. So I think on the multiple GPU, because the main issue right now is that if I use multiple GPUs versus single GPUs on inference, it's slightly faster on single GPU versus the multiple GPUs. But with the data loader implementation, I was able to save 1 second, but I think it's can possibly be better than that. So I'll take a look at that after I do more on the correctness runs. So I'll kind of put that in the back burner just for a bit. And then I did a few benchmark runs on both Tiny Box Screen and Reds, and I think on the Tiny Box Screen, if I remember correctly, I posted it. I got roughly around 22 hours. So there's that run right there. And I think the AM GPU is actually pretty stable. I'm able to do continuous benchmark runs a few days ago, so I don't think I have any problems with that so far. And then I also started my first run as well, for the first correctness run rather. And I just found out that after the first epoch, I needed more memory for eval. So I'm gonna add some sort of a JIT reset, I think, which is what we do in like ResNet and BERT as well, which we have it turned on, I think, optional. So I'll do that as well. And then also notice that the loss function right now is kind of declining pretty slowly, and I think I probably went pretty small on the learning rate. So I'll have to adjust that as well, and do it like a smaller run as well, just to see if it actually goes down much faster than expected.
Yeah, so I think what was useful before was, so for learning rate, you can check other people's submission, see what their global batch size and learning rates are. And I think it's also useful for you if you can find a workflow to find the issues like you just mentioned, like you are out of memory, because these things you don't need to wait for the whole beam setup and the whole first epoch or whatever to figure it out.
Okay, sounds good.
Yeah, basically see what you can copy or learn from other people's submission, and you should definitely get a dedicated red machine if you want to run back-to-back runs. But I think it's still valuable for you to find a workflow that you can iterate faster.
Oh, I had a question about the examples. Are you referring to like the other submissions from other teams, right? Not
Yeah, from other teams.
okay, because I was using. Go ahead.
No, I think there are a lot of people, they use very big batch size and maybe a very aggressive schedule, like learning rate and stuff. But usually for BERT and ResNet, if you go back a few rounds, it doesn't need to be the most recent round, but you can see the previous ones and find the one that has similar batch size. And that should be a good reference point for how you want to schedule your learning rate and stuff and other hyperparameters.
Okay, sounds good.
Okay, it's an hour already, so let's speed up. I don't see thumbs up here for Graph Rewrite 2.0. For George, if you have any comment on that, I don't know what's happening to that.
I haven't seen updates on it in a while.
Okay. We'll figure it out. So for the flatten add chain thing, I would take a look for the commutative flipping thing. I think that also fix a bug, so we definitely want to understand what's happening there before bringing it back. But let's need it. Definitely need for that.
It fixed 2 linearizer failures on Metal. I don't know why.
Okay, I will check that.
Oh.
And finally, the decoder for MV driver. I think you already commented on that.
Yeah, so they wrote one in using the Qvid API, using NV Qvid. They'll have to rewrite it in the NV driver, but NV Qvid is the first step anyway. Just look at the IO controls, figure out how to send the IO controls. It's overall very simple. If they see this in the replay, no need to worry about like raw bit streams are fine. The user can do demultiplexing of the bit stream. That's all pretty easy. I mean, these things are so small relative to the pictures they blow up to. But yeah, no, it'd be awesome to have support for that in NV, and then that's our first kind of tensor that comes from like a magical source. Like it's a tensor that's sourced from something else, which eventually gets to like how to put really fast data loader pipelines into TinyGrad. They can automatically do that, like HVAC for you and stuff. So, I think I'll have, if that bounty works out, I'll add more bounties for things like adding JPEG decoders and anything we can use accelerated on the GPU.
Great. Okay, that's it for the agenda. Any last word?
Yeah, so I wanted to talk about the there's a whole lot of I'm gonna move the AMX one down. Yeah, AMX one's kind of special. There's 1, 2, 3, 4, 5, 6, 7, 8 bounties for speed. Some of these speed bounties, some of these $300 speed bounties are solvable with like 2 or 3 lines of code. So they're easy ways for new people to get into TinyGrad. I posted the exact command there you have to run. Just figure out how to make that command fast. And yeah, I think there's what I really like about those bounties and why they're good for new people is because there's no real way to like not know that you did it. Like with a refactor, you have no idea if you did a good job or not. You're just gonna have to, maybe submit. Maybe this is the kind of thing where you can get in a loop and you can be like, okay, I made this change and it got 10% faster. Okay, I'm still 2x off of torch. How do I make it faster, right? Like that's a loop that you can work in by yourself and improve. Hopefully it's addictive. Hopefully you'll come work on speed and TinyGrad. This is who we want to hire full time. I will definitely, like our next full-time hire really has to be somebody who can sit with these kernels and improve the speed of them.
Great. I will probably also promote those bounties.
Cool. Yeah, no, I mean, they're
Yeah.
good. Like a lot of people are thinking about this stuff with kernels and
I think, yeah, it's also good because it's kind of standalone-ish.
yeah, most of them are probably just going to be adding
and the
like
value is also clear. You made this thing fast. Okay, that's nice. Okay, that's it for this week. Thank you, everyone, and see you next week.
Bye.